Again,
we're not going to go into great detail about carbohydrates, but because we just learned a reaction that is very typical of carbohydrates and is very important for their behavior, we're going to take a look at the formation of hemiacetals with carbohydrates. Okay, reminding yourself what a hemiacetal is, you take any aldehyde or ketone and react it with a single equivalent of alcohol in the presence of a little bit of acid, you're going to get a hemiacetal. Now that hemiacetal is normally not very stable, and usually, depending on whether you use excess alcohol or not, if you use excess alcohol, the reaction will move forward to form the acetal, which is more stable. If we add excess of water, we drive that reaction back to the starting material. But in the case of something like a carbohydrate, where an intramolecular reaction can happen, well, hemiacetal actually ends up being more stable than hemiacetals for an acyclic system like this. Okay, so we had started yesterday by introducing carbohydrates to you, and so this was an example of a sugar. This is D-ribose. D-ribose has all the typical components of a carbohydrate. It has the aldehyde group at one end of the chain, and every other carbon has an OH group. There's a particular stereochemistry. This, of course, is a Fischer projection, and the Fischer projection indicates a particular stereochemistry. Just to remind you how we draw Fischer projections, usually we place the crosses on the main vertical line wherever there is a stereogenic center. This last carbon is not a stereogenic center, so we don't bother to separate the two H's and the OH from each other because there's no stereochemistry at that position. Similarly, we don't write out the aldehyde group in full because it's not a stereogenic center. So this was D-ribose, and we then practiced a little bit with representing carbohydrates. And so I'm going to give you some practice again with a different carbohydrate than the one that's on this screen, because I do want you guys to practice doing Fischer projections. Being able to draw Fischer projections for these systems is very important. So this time I'm actually going to give you a ketone.